How are you guys? Welcome back to my YouTube channel. Today we'll be dealing with Mechanotechnics N6, which we'll be dealing with, and we'll be under module one. We'll be dealing with module one and clashes, but we'll look at single plate clashes. Right, this is an introduction. Please, if you have not subscribed to my YouTube channel, please subscribe to my YouTube channel and click that notification button so that you can be notified whenever I post a new video. Thank you. And also feel free to comment and also to share on your fellow classmate. Okay, let us indulge. A given says introduction. As you can see, this is an introduction. This is a new topic, right? We did not do clashes. Remember on our previous N5. So let us just the significance, as you can see, the significance function of a clash is to connect a rotary gear to a stationary one. This must be done such a way that the smooth overcome inertia in order to accelerate the coupled gear necessary speed. Okay, no problem about this. I want us to deal with what is very important. Otherwise, okay, here we have, this is the clash, as you can see. Hopefully it is a clash. As you can see, this is our clash. You can zoom like that. You see, this is a clash. This is our clash. It's a single clash, as you can see. Right. Hopefully you know this clash, especially if you did diesel mechanic, you'll understand this is a clash. It's a single plate, right? So the number of contact when you are dealing with a single plate, if you are dealing with a single plate, you must know that the number of contact must be equals to 2. I mean n will be equals to 2. Remember, provided that both sides are effective. But all I know, when you're dealing with single clash plate, number of contact will be 2. This plate, this and this will contact this disc, both sides. So the number of contact will be 2, the number of contact, whereby the number of contact is equal to 2, right? So yeah, which is represented by n, it's equal to 2, right? So that was a single clash plate so far. As you can see here, we'll discuss about this uniform weight theory or uniform pressure theory. We'll discuss about these two so far. Okay, enough with story. Let us indulge here. I want us to check. You see here we have 1.3 says plate clashes. This one is a multiple plate clash. As you can see, this is a multiple clash plot is shown in figure 1.2 below. Clashes are available in a single plate from a shown figure 1.1. The plate are subjected to a axial force when as you can see, when the clash are engaged, right? This is a multiple clash. So as you can see, the multiple clash, there's an important thing that you must note here we have a note. We say in a single clash, you can see in a single clash, I have highlighted that in a single clash both sides of a plate are effective, right? As you can see, and 2 contact surface are considered. You see 2 contact surface, which is will be n. We'll discuss about this n. This is the number of contact at n. When we're dealing with a single, check, when you're dealing with a single clash, they will tell you in a single clash there are 2 number of contact. But however, as you can see here, however, in a multiple clash, all the surface pairs contribute to the torque in transmission. So that means here will depend And this is a multiple clash. As you can see, this one, it's a multiple clash. Why? Yeah, as you can see here, you have clash plates. Plate, the one there is S there. That means you have 1, 2, 3. As you can see, we have 1, 2, 3. So as you can see, we have also have a disc plate, clash disc. We have 1, 2, 3. So this one is a multiple, is not a single. If it's a single, supposed if it is a single, we consider only these two parts. We see this must be a la, and only this part will be a single part. This is not a single, it's a multiple, right? So as you can see here, it says for a single plate clash, there are two contact surfaces. As I have told you guys, there are two, which is this is a number of n. There are two when you're dealing with a single, and the normal force is the same. As you can see, that the important thing again here, it says the normal force. You can see here the normal force. The normal force is the same as the spring force, as well the same as the axial force. You have given there Fn, which is the normal force, is equal to Fs, right? Spring force plus Fa, which is the axial force. You have given this. Are dealing for what? For a single clash plate. It's what we know. For single clash plate, normal force is equal to this here. Normal force is equal to the spring force and axial force, right? Is what we have. Okay, right. This is what we have. Then they say all formulas applicable to a single plate clash also apply to a multiple plate clashes as well. That means all the formulas that we'll use for a single clash plate will be also used to a multiple clash plates, right? So how do we find the number of contact of a multiple clash plate? They've given us here, they say it is only the number. You can say here the multiple clash plate, it's only the number of contact surface that diff. The number of clash plate, the number of contact surface, it differs from the single. The single one we know that is equals to 2, the number of contact surface. But when you're dealing with multiples, there will be a differ. Now my question: how do we found the number of that? They've given us the number of contact surface. The number of contact surfaces differ where n, they've told us where n, that means n is equal to sum of rings. You see sum of rings there, sum of rings and plates, sum of ring and plates, right? Then you subtract 1, right? So in such a way, if you are given plates, let's say now you're given sum of rings only, or you are given plates, will be n will be equal to what? The sum of what? Sum of plates. Sum of plates will just be equal to sum of plates, right? Minus 1. So this thing of mine is giving me trouble. N will be equal to the sum of plates, right? Sum of plates. We subtract 1. This is what you're supposed to have. This is what's supposed to know. So so far formula now 1.1.3 calculation for clash, for plate clash. Right. Before we look at some solve example, let us look at the formula and symbol we need to do calculation for plate clash, right? Okay, formula and symbols. As you can see, uniform wear. Yes, right. We have a uniform way. That is the theory by its own, uniform way. Let me highlight. As you can see, let me use my highlighter there. I can use my highlighter like that, or let me just let me not use this scale. Let me just apply my highlighter. Hopefully it's not that much thick here. Uniform way with that green. As you can see, uniform way theory, it's associated with one clash, one clash, or used clash, second hand clash. This is what we're talking about. It's only when we'll use uniform wear theory. It's only when our clash, if you buy a second-hand clash, we'll use uniform wear theory to calculate the calculations to use to calculate what we want to calculate, right? Now that it's a theory, it's a uniform wear. Uniform wear is associated with used clash, old clash. Here, old clash, old clash, one clash, old clash must be old clashes, right? Old clash. Talking about old clash. This is will use the theory that we'll use. We call it uniform wear theory. Whereby when we calculate, as you can see here, RF, right, will be equal to R plus R over 2. Remember, this is R, it's the outer radius of the disk plus inner radius of the disk. Divide this by 2. Divide this by 2. We've given RF, yes, you can see here, RF is the effective friction radius in meter. R is the outer, as you can see, R is the outer radius. As you can see, R is the outer radius of friction disk measured in meter, right? As you can see, this one also is measured in what? In meter. RF, the effective friction. As you can see, that is an effective. Here, this is an effective friction radius. Also, do you see is an outer? I've highlighted there. The small capital, the small letter is inside the radius of refraction disk, right? This is the formula for uniform wear. When you calculate RF, is very important. This formula is very important. This formula is very important, right? So this is what we're supposed to know, right? It's very important, this formula. So now that was a uniform. Now we have two theories. We did uniform, right? Now we have again another theory, uniform pressure theory. Oh, now when we are dealing with uniform pressure theory, we're dealing with new clash, the brand new, the one that you buy at shop, or brand new clashes. These are not second hands. We're dealing with new things, new clashes. When you go to the shop there and you buy a new clash, this is for new clash, new one. You understand, guys? So how do we calculate the effective radius? As you can see here, the effective radius. How can we calculate the effective radius there? The effective radius, as I've highlighted, now will be given by, as you can see, effective radius RM. Now it's RM, as you can see, is 2 over 3 into R. You see that cubed minus R cubed over R squared minus R squared. As you can see, this is how we calculate RM. Now the effective friction radius, right? When you're dealing, this you talk about when you're dealing with a brand new clash, when you're dealing with new clashes, guys, when you're dealing with new, as you can see there, I've shown you new, when you're dealing with new things there, right? When you're dealing with the new ones, new or brand new, this one is not a second hand. Then how we calculate our things, we'll call it, that theory will be uniform pressure theory. Uniform pressure theory is for new, as you can see. Okay, let me drink some water, guys. Right. So far we've discussed about this. We know the difference. Another thing we must note, R, this top part only. R plus R. This is actually, if you're given mean diameter, mean diameter. If you're given mean diameter, right, d mean, that is simply mean diameter. Let me just say, let me write it here. For example, if you're given R1 plus R2 is simply equals to mean diameter. If you're given a mean diameter, will be equal to mean diameter, right? These two here, R1 plus R2 will equal to what? If you're given a mean diameter, will be equal to mean diameter. But however, our formula has over 2, then that means this mean diameter, you will divide it by 2 if you're given a mean diameter. Do not make a mistake. Mean diameter is the same as R1 plus R2. Mean diameter is the same as R1 plus R2. Already you have R1 plus R2. Then you can divide that by 2. But now you're finding that is R. Now if you're wanting, but what is important actually is this, is that, let me erase these 2 for now, because when we put 2, that means now we're talking about RF. But I want you to understand this. I want you to understand that R plus more let's big capital letter R, outer radius plus inner radius is equal to mean diameter. Hopefully you understand. Thanks. So given a final speed in revolution, okay, we will discuss about this formula, guys, how to calculate the speed there. This one, do not worry about this a lot. We'll discuss when you are dealing with question. You will see it. You know, calculate the speed will equal to angular acceleration of the shaft multiplied by the speed of the engine over the angular acceleration of the engine plus the angular acceleration of the shaft. We'll discuss about this. We'll discuss about this when we are dealing with questions. So understand axial force. See, we have given axial force. We have a first formula here. FA here, I've highlighted axial force there. As you can see, FA is equal to P mean. Okay, this is the pressure multiplied by pi into R squared minus R squared. Do not be confused. Do not be confused, guys. This is simply area. This part, it's an area, just an area. Remember, force. Okay, let me just do like this. Pressure is equal to force over area. Now we want the force will be equal to pressure multiplied by area. But you relate, here is the pressure, but our area is that one. Now the area here, as you can see, is given by pi R squared minus R squared. This is in what? Simply an area. All right. Cool. Right there, we're dealing, you must be take note. It's when we are dealing with you see, for mean pressure, it's a mean pressure. That means all mean pressure will occurs when you're dealing with will be neutralize. Mean pressure obvious is for neutralize, right? Then we have here a second formula. Second formula here. As you can see, axial force is equal to 2 pi r into r minus r multiplied by p max. Okay, and then we have this p mean. We'll discuss about this for maximum pressure, for minimum pressure. For that, we'll deal with question. You'll understand when dealing with question. The most important thing again here, we say calculate friction torque. Here is the formula. Friction torque, as you can see, you have T, it's equals to coefficient of friction multiplied by axial force multiplied by RE multiplied by N. Good. Now, this RE depends, as you can see, let me highlight. This RE effective radius depend of the wear, whether the wear is applicable, depend on the theory which you are applying. Remember, this R can be either for, if you are given a pressure theory, remember will be 2 over 3 into R cubed minus r cubed over r squared minus r squared. Uniform pressure theory. But if given uniform weight theory, if you're given uniform weight theory, we'll have r plus r over 2. This will depend on what theory you're given. It's either it'll depend on you're dealing with old clash or the new clash. You understand me, right? Yeah. So this is how we'll calculate our axial, the force there. I want to discuss the force. The axial force also will differ, will depend whether you are dealing with old or new clash. We are dealing with that now to calculate this n. This n is a number of contact. That n is a number of contact. Number of contact surface. I've shown you there. All right. So to calculate time, here as you can see the time will equal to angular velocity over angular acceleration. Yeah, we'll see. Then the change in Fs is equal to the total wear multiplied by stiffness multiplied by number of springs. But where they say note this total wear, but total wear, but the total wear is equal to what they've told you. It's wear is equal to number of contact multiplied by wear per surface. Number of contact multiplied by wear per surface, as you can see there. But total wear only is that, as you can see there. Yeah, I must understand that. So yeah, power does not change. The formula of power is the one in the same thing there. So far, since we have discussed, let us solve example. Here we looked for different theories. We have looked at the different theories, right? Application to plate and the formula. Calculation related to term described explaining example that follows. Okay, let me just look this, then we'll apply according. Let us deal with this example so that you'll understand this as we are dealing with this example. Hope you're with me there, guys. All right. Example 1.1. So we're dealing with a single, check there. This is a single plate clash. Right, single plate clash. With both side effective. So single, all I know when you're dealing with single plate clash, the number of contact there, the number of contact must be equals to 2. Must be equals to 2, the number of contact. If you are dealing with single clash, number of contact must be equals to 2. All that I know. Right. Number of contact, if you are dealing with single plate clash, if they're just giving you some extra. You see here, they give you some extra information with both side effective, but all I know, the number of contact that you are dealing with a single clash will be equal to 2. Always. I don't know, maybe they can try to adjust, but all I know for I, as a diesel mechanic, all I know, 2 will be, unless if only one, but if the one is broken, the other one is broken, that means is that I cannot operate, but will be 2 number of contact surface. Okay, here's they will let enough for the stories. So let us check here. Here's an inside diameter of 208. That is what we have there. You see this both sides has inside diameter. Remember dealing with the inside radius, what remember dealing with here, this is an inside radius or diameter, but us will be using, when we calculate, we are dealing with radius, guys. So that one will be simply just As you can see, that is just this is simply just a diameter there. It's an inside diameter, and outside diameter is 380. The pressure plate is limited to 200, limited to 273 kilopascal. The coefficient of friction of the material, we have given the coefficient of friction. Okay, it says now given to calculate the following. Number one, calculate the following. Number one here, as you can see, we have the number one. Number one, you should calculate. What is wrong with this thing now? Why it does not touch? So I think the stylus pen has a problem here. Number one says the axial force available if the clash is new, guys. Oh, that is very important. New. Remember, I said we're dealing with two theories here: old clash and the new clash. Remember, note that if the clash is new, when the clash is new, we're dealing with what? Which theory? Uniform pressure, guys. Uniform pressure theory. This will be uniform pressure theory that we'll be dealing with. I've discussed with you here, guys. Said when we are dealing with the new things, we'll be dealing with what? Uniform pressure theory. When we are dealing with new things, it's a uniform pressure theory. Right. So uniform pressure theory. So otherwise, let me just say, let us find the data given for, okay, what are we given here? Inside diameter, I'll call it D, like that, is 280. When I divide by 2, by 1000, sorry, 280 divided by 1000 would be 0.28, right? But now remember, we're dealing with the radius. Remember, the inside diameter must be associated with what will give us inside radius, because it's an inside. So this one, when we divide this by 2, if we divide that by 2, will give us the inside radius, right? Divide that of 0.14. This is in meter. Let's check the outside diameter. They said let's check our data. Outside diameter is 380. When you divide 380 by 1000, we'll have 0.38, right, in meter. Then we divide this by 2. Then what will be our, what is this, our outer radius? Remember, it's associated. Remember, it's outside diameter must be associated with outside radius. Then if you punch, that will be 0.19, right, meter. Fine. So this is what we have. The important things is this and this. We'll use this radius. So what else we have? The pressure is limited. Okay, it's limited. It's not a minimum. They say there is not. They did not say maximum. They did not say. They said limited. They did not say maximum pressure. That must be okay. Must be limited, which is here or what? Okay, let me just say P min. No problem. You'll understand this, guys. This is the pressure. But it's not necessary to write what P min and what. But let me just write P min. This will 273 kilopascal. This is our pressure. Then we have the coefficient of friction of the metal, which is 0.3. Coefficient, which is 0.35. This is what we have. Now 1.1 axial force available if the clash is new. Dealing with the new clash, note there. Axial force in the formula, I can say number one, we're dealing with axial force, isn't it? So um I don't know what's wrong with this pen, but so we're given number 1. Sorry, I had a problem with this pen. Okay, it's fine. Okay, now one day axial force if the clash is new, axial force will be Fa. Which formula will we use here? We have these 3 formulas. For mean pressure is this one. Limited, this one we'll use, is associated with what? That is the formula that you're supposed to use them. We are not given the maximum pressure, not given the minimum pressure. Just limited will be P mean. That is one we'll use. We'll use this one. Calculate the axial force. So as you have seen there, the formula will be P mean multiplied by area. We know that force is pressure multiplied by area, but our area is equals to simply just pi into r squared minus r squared. So what is this? Is 273 times 10 to the power of 3 is here given there, multiplied by pi. Here we are given in our data, isn't it, kilopascal. Then what is r? R is 0.19, as you can see there. That will be 0.19. We square this minus small r, which is 0.14. We square this, then punch this on your calculator, all this, then supposed to get that. If you punch, accuracy will be 14151,304 Newton. But I've talked something. Remember, what is this? It is a single clutch plate. For recap, remember I said, for recap, for extra, let me say, determine again normal force or friction, or I can say calculate the normal force. I'm just adding a question. Determine the normal force or spring force. But I've told you, I said when you're dealing with a single plate, the normal force, I've told you, normal force is the same as, right, normal force is the same as, you see, spring force and axial force. So these things are the same. Where did you get this guy? I've discussed about this here when we're starting here. We have talked here. If you listen to me, they've told us normal force is equal, as you can see from here, this is the normal force. The normal force is the same as spring force as well as the axial force there. Yeah. Now, so we know the axial force. So that means all of these things must simply equals to 1. For remember, these things are the same. Remember what we have calculated, there was axial force. So that means all of these 3 things must be equal to this. All of these. Alright, because this is the axial force. Right. Okay, no problem. Then number 2, the maximum torque that the clutch can transmit. Oh my torque, torque. The formula for torque is coefficient of friction multiplied by FA multiply by RE multiplied by N. But I've discussed, guys, this RE will depends whether you are dealing with uniform wear or uniform pressure theory, uniform wear theory or uniform pressure theory. So when you are dealing with uniform, we are dealing with new or brand new clashes. Here we're dealing with one old thing. So let's check actually what are we given here. They says new clash. If the clash is new, then we're dealing with uniform pressure theory. That means now we'll be very careful here. So we'll be dealing with this one, and then remember this RE simply will be equal to RM for that, whereby we know for will be 2 over 3 into R cubed minus R cubed over R squared minus big R squared. Remember, this is the formula for, isn't it, uniform wear. This is what you're supposed to know. So let us calculate it. RM we can say is 2 over 3, isn't it? Yes. R cubed minus R cubed over R squared minus R squared. Then let us substitute our things. 2 over 3 into big R, we know that is 0, 0.19 cubed minus 0.14 squared is all over 0.19 squared. Oh, sorry, here we're supposed not to be squared. Do not do that mistake that I did here. Must be cubed. Right here at the bottom must be squared. 0.14 squared. Following the formula, right? So here, remember, if given small r is 0.14, there is 0.19. Yeah. So if you punch this, let's check what do you get. I think when I punch this, let me say get 0.166 meter, right? 0.166 meter. Now I have this. I have this. So let me calculate our torque. F Asia multiplied by coefficient of friction multiplied by RE multiplied by number of contact. Then what is our force? Asia, we've calculated it. Obviously, you must be very careful. The maximum torque that the clutch can transmit, obviously we've calculated with, we have dealt with a new. So when you calculate the torque, also must use the force that we've used of the new clutch. The axial force is the one that you have calculated there, which is 1. We'll use this. We have it there, which is, remember, we got that was 14151,0, or not 0.34, right? Coefficient of friction here is coefficient of friction is 0,35. 0,35 times this. You have calculated it right now. This we did calculate here. Here it is. Is 0,166 multiplied by number of contact, which is 2. Remember, dealing with a single glass plate. I've talked about this single glass plate with both sides effective. I said when you're dealing with this, we'll have 2 number of contact. Then punch this on your calculator stuff. Supposed to get these to be equals to, if you punch all of that, we'll get 1,6. Remember, this is torque 444,382 Newton per meter. It's measured in Newton per meter. This is what you'll have there. Right, so we're done with this talk. Let's check number 3. The axial force now available if the clutch is what is on. If the clutch is on, assuming that the pressure limited, assuming that the same pressure limited. Okay, they say we're assuming they did not change the pressure. They say let us just use the same pressure that they've given us. That is what they are saying there. They want the axial available if the clutch is on. What is the formula that we'll use? If the clutch is on, this one will use the number 2 one here. We'll use that. Then what will be the formula there? Number 3. This is the one stuff there. For 1, that will be 2 pi, must know 2 pi r, right, into big R minus small r multiplied by P, pressure max. Okay, here is 2 pi. Our R is 0,14. Then this radius, big one, is 0,19 minus 0,14. Then the pressure, they said we use the same one, which is 210 that multiplied by 10 to the power of 3. And then if you punch this on your calculators, you're supposed to get that. This force, the axial force, should be 12,007,167 Newton. If you divide this by 1,000, if you want it to be kilo, divide this by 1,000. If you want it to be in kilos, will be 12,007 kilonewton. It's up to you. As you can see, it's either you leave it here or here. It's one and the same thing. So we are done with that. Let's check number 4, last question. The maximum torque that the wound clutch can transmit. The wound clutch, obviously, already we have the axial force for wound clutch. We've calculated it. We'll use for wound clutch is the one that we've calculated here. So number 4, they want the torque. The formula does not change for torque. Will be one and the same thing there. Then the torque does not change the formula. The formula will not change What is wrong with my pen? Sorry guys, this pen is doing some. Okay, we know the formula will be right. Coefficient of friction multiplied by axial force multiplied by Re multiplied by the number of contact. Coefficient of friction we know 0.35. Axial force is the one here. We've calculated it. Here it is. Then sorry about that. Sorry about this. Not this time. Sorry about this, guys. Sorry about that. Anyway, we said we are here. Want to calculate the axial. We said it is 12,007, 12 007,167 RE. Will change now. You can, if you use this one, you are doomed. If you use this one, you are doomed. It will be wrong. Remember, this was is for new clash. But we are talking about where they said the clash is won. Remember now, for one clash, I've discussed about this RE. Now we'll change this R. This RE, this will be RF, right? We'll use that one. Simply equals to RF. But we know this RF is equals to R plus R over 2 because this is a uniform weight theory. Then our R we know is 0.19 plus 0.14. We divide this by 2. If you divide that, you're supposed to get this to be 0.165 meter. So here now we have this. You can substitute there. It would be 0.165 multiplied by the number of contact. Obvious, it does not change. There is 2 still under single clash there. If we punch this, what will be the torque? We'll have 1386,828 Newton meter. This is what we'll have. Right. So this is what it is, guys. This is what is it. This was the last question. This is what it is, guys. You'll see this formula. We'll deal with this comfort. This formula, we'll use them if you keep an eye. Just subscribe there. Keep an eye on my YouTube channel. I'll be posting a second session. Right, you'll see these formulas. How do you apply? How we go about. So guys, thank you for your time. Please do not forget to subscribe to my YouTube channel. Please do not forget to subscribe right to my YouTube channel. Click that notification button. Share this to your favorite classmate. Thank you guys. May God bless you guys. Study there. Have a nice day, by the way. Thank you.